Okay, here guys. Hey there. Welcome back. This is your Unit 1, Lesson 2, Part 2. I got that right. Unit 1, Lesson 2, Part 2. This is hard axis. So it's kind of a little bit tricky situation, so I just wanted to make sure we had some time where we sat down and just did hard axis. We will go over this in person in class next time. Take the notes now, try to learn it now, and then I will review it on Monday. It's better if you learn it now than and review on Monday versus starting from scratch. So we still have time to do our skills on Monday. Okay, so let's get into this. So what the heck is hard axis anyway, by the way? So hard axis is like it's the angle at which the heart sits in the chest. I'm like, just like this guy, how it sits in the chest. Get it? My sense of humor. Yeah, so it's basically at which angle your heart sits in your chest. And we base the angle on where the apex is located. So the apex, the point of the heart, the little point at the bottom there, should be pointing in a very specific angle or area of your heart. So we're going to build like this little wheel that kind of describes which angle it is. I'm sure you've seen the angle wheel before in other things in mathematics and all that. So it shouldn't be too much of a new thing. It just we have to put it into like where the heart actually sits in the chest. Okay. Now it can change position. So your heart can move positions inside your body based on what position you're in. So if I'm sitting up versus lying down, my heart axis might be in a little bit different position. If a pregnant woman has lots of stuff down in the bottom of her belly, right, and it's pushing up on the heart, it can actually push the heart axis up a little bit. Once you lie down flat, things kind of like spread out a little bit, if you know what I mean, and the heart axis can change that way too. So we're actually going to take EKGs when we do stress testing later in this program. We do take resting EKGs in a couple of different positions so that we can see the angle, the different angle of their heart axis. Okay, so this is all about heart axis. All right, so you have this really cool on your paper right here. Letter N says heart axis, and you have this wheel. We're going to finish the wheel together. So don't worry about this right here because I'm going to draw it on my camera and we can follow along. We'll come back to this picture after. Okay, so let's make sure we got our wheel correct. And then we'll put in all these letters and numbers after that. Okay, so let's open up my camera real quick. All right, so you can see. Here is my wheel, right? And this is what your notes look like as well. So this is my wheel. And you can see it's a circle, basically, just cut into 4 different sections. So each one of these sections, you need to make into 3 pieces of pie. So in thirds, basically. So I need to put a line here, I need to put a line here, I need to put a line here and here. See what I'm doing? It's kind of making a wagon wheel. So each of those 4 sections of pie become 3 sections each. So it kind of looks like a wagon wheel. Pretty simple, right? So next thing we're going to do, this is 0. So this is degrees, obviously. So when thinking of, when you think of a protractor, perhaps, you think of all the degrees in the protractor. This is 0 here. And then we're going to continue around the wheel. And of course, this is 180. But this is going to be plus or minus because everything up here is considered negative and everything down here is considered positive. I know that seems different than our isoelectric line, right? Because everything above the isoelectric line is positive, everything below is negative. But hear me out, we'll get there, okay? I know, it seems backwards. All right, so as long as you have that in there, so we have 0 and 180, I'm going to flip-flop over to the other picture just so you can see. So as you can see, we're going to label it positive 30, positive 60, positive 90, 120, 150, negative 30, negative 60, negative 90, 120, negative 150. So that's what we're putting first, the numbers on all of these wheels, all the spokes, if you will, of the wheel. Okay, I'll go back to my picture so I can do that with you. We'll draw it together on my wheel. Make sure you're writing the plus and the minus as well. So this is a positive 30, a positive 60, positive 90, positive 120, positive 150. So you can see they go up in increments by 30. That makes sense since this is a 90-degree angle and it's broken into thirds, right? 30, 60, 90. So we'll go the other direction. It'll be negative 30, negative 60, negative 90, negative 120, negative 150. So all of the spokes of our wheel are labeled. So make sure that the numbers are on there. Okay, got the numbers? All right, so your wheel should look like mine. And if you're still writing them, it's okay. When I close this, we'll still see the picture, the slide picture of it. So you can see right here, 0, positive 30, positive 60, positive 90, 120, 150, 180. So if I took a heart and I stuck it right in the center here, and the apex is pointing down this direction, say it's pointing right here, then the apex is pointing right here, then the heart axis would be positive 30. Okay, now notice that there are, and if it was pointing kind of down, it would be positive 90. Okay, so notice that there are six limb leads here, augmented, and leads 1, 2, 3, and our augmented leads are all coincide with different angles here. Okay, so negative 30, I want you to write next to negative 30, AVL. I'm going to put a box around mine just so I can see it a little better. And 0, put Roman numeral 1, positive 30. Now notice how this is written in a negative AVR. There's a reason for that, and I'll show you why in a moment. Okay, so write it negative AVR. And your 60 is 2, Roman numeral 2. Positive 90 is AVF. And positive 120 is 3. So we're only concerned about our 6 limb leads. Okay, that's all this has to do with. So when we look at our EKG itself and we're looking to determine the heart axis, we are only using our 6 limb leads. We're not using V1 through 6. We're only using 1, 2, 3, AVR, AVL, and AVF. Okay, based on the wheel right here. These 6 are the ones on the wheel. Okay? All right, I'm going to show you mine so you can see what yours should look like. Should look just like that since you hand wrote it. So here's mine. Here's my 0, right? Is 1. AVL is negative 30. Now make sure you write a negative AVR, and I'll show you that why in a moment. And then we have 2, we have AVF, and we have 3. Okay? And they all coincide with a different angle on the wheel. And you're like, what about these up here? Do we use those? We do in certain situations, but we'll get to that too. Okay, let's do the basics. This is the basics right here. Okay. Next thing we need to do is we need to go over like what is a normal heart axis, right? A normal heart axis, meaning where the apex, if this is my apex, is sitting in my chest. If it's pointing here, 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 if it's, whatever angle it's at. Clearly it would be not normal if my apex was if my heart was upside down, correct? That would not be normal. No, it wouldn't. So we'll find out the range of what is normal. Okay, so click on this. So anything from negative 30 down to 90 is going to be a normal axis. So next to my wheel, I'm actually going to kind of color it in or shade it in. So I know that this is the normal range. Oops, I went a little too far on mine. So negative 30 to positive 90 equals normal. That's the normal axis. And I'm going to show you my picture. So you might want to do it similar. Up to you. I started to color over here. This is not right. It should go just to here. So I'm going to darken it here to here. I started to color in the 120. That is not correct. Do not color here. Okay. So negative 30 down to positive 90 is considered a normal axis. And here it is right there. I wrote on the side here, kind of in the margin, negative 30 to positive 90. And this is degrees. If you want to write little degree symbol, you can. This is the degree, the angle at which your heart sits. So if my apex is pointing anywhere in this little piece of pie, in this angle, in this area, it's considered a normal heart axis. Okay? All right. If you didn't get that, go back and review. You can rewind and redo. Okay, so the next one is called the right axis deviation. So that means if it ends up pointing a little bit this direction instead of this direction, it's pointing more towards the right. Remember, this is the patient's right. So it's pointing a little bit to the right. It doesn't make it extreme or crazy or anything like that, but it just means it's kind of pushed a little to the right. And sometimes there's a tumor in there pushing it. There's, again, pregnant women have stuff get squished all over the place in different angles. It's not going to do anything wrong to the heart. It's not going to make it bad. A right axis deviation is usually nothing to worry about. The apex is still down below. Okay, so on your paper, this is going to be, I'm going to darken these up again. And I'm going to kind of do little swirls, just so it makes it look different. Or if you want to use a different color, I actually realize I have green here. So my right axis deviation is going to be that positive 90 to plus or minus 180. Okay? So I kind of shaded it in a different color, or you can shade it in with something different. What we really need to know is the normal axis is negative 30 to positive 90. And right axis deviation is not anything to worry about clinically. Okay? So I'll show you my picture that I drew, and we'll come back to this one. Here's my little picture. Here's my wheel, my wagon wheel. So you can see I have the negative 30 down to positive 90 is normal. I shaded it one color. The right axis deviation is positive 90 to negative plus or minus 180. So that would mean the apex would be pointing in this direction. Okay, pointing towards this direction, which again is not clinically too bad. It's not going to throw much of things off. Okay, when we start having our heart upside down and your axis deviations up here, we have a problem. That means your ventricles are above your atrium. Difficult to kind of move blood that way. Okay. All right, let's go back to the presentation, and we'll talk about the left axis deviation. This is a very small window. It's just negative 30 to negative 90. So I'm going to do this in green again just because it's on the other side. So left axis deviation. And again, that makes sense because this is the left side of the heart. And since now the apex is kind of up in the air a little bit, it does make it a little bit wonky. And your EKG is going to look a little bit different than a normal one. So this is negative 30 to negative 90. So we have 3 sections already. We have the normal axis from here to here, right axis deviation from here to here, and left axis is this little piece of pie. It's these 2 pie pieces together, negative 30 to negative 90. I'll show you mine one more time. It's my picture. This is kind of what your notes look like. My notes are kind of messy. Hopefully you're a little bit more organized than I am today. Here's my normal axis, and I wrote it here, negative 30 to positive 90. My right axis deviation is positive 90 to plus or minus 180. Right axis deviation, I wrote it here, and I kind of colored it in separately. And then I have my left axis deviation, meaning the apex would point up here. So the apex of the heart would be kind of pointed, squished up here. Again, we see this left axis deviation a lot in pregnant women, just because, especially if they have a big belly and it's pushing up on their organs when they're sitting, it's really squishing it, so the apex gets squished up. That's really all that is. So that's a small little window. It's the negative 30 up to negative 90, and I wrote that up here. So last piece of the pie here we have here. This one's going to be called extreme axis deviation. So let me close this and we'll write it down in here. Extreme axis deviation. So that whole section there, which is going to be negative 90 to plus or minus 180. Extreme axis deviation. So what you're writing down is you're kind of shading this area, and you're writing down negative 90 to plus or minus 180 equals extreme axis deviation. And again, I will show you my lovely drawing, which is not so lovely, but it gets the point across, I hope. I don't know why it jumps like that between everyone, but it does. Okay, so here's my extreme axis deviation, and I did color it in just a little bit differently than the other one. and it's negative 90 to positive or minus 180. Extreme axis deviation. So our heart does not wake up one morning and go, hey, I think I want to be upside down today. Okay, this is not a normal situation. You were born this way, or you've had some sort of traumatic accident or injury that has put your heart in a wrong place. Okay, this is a very extreme traumatic type of situation. Your heart will literally be upside down. Okay, again, it does not wake up one morning and be like, I think I want to be in extreme axis today. That's not how it happens. Okay, so I don't see this very often. I do see left axis and right axis pretty often, but most people fall into the normal range. Okay. All right, so what does all this piece of pie mean? So I need you to know, you need to see this pie first, this pie chart first, to kind of understand where we're going with this. And don't forget that we have AVL 1, AVR 2, AVF, and 3 down here. So let's go ahead and go back to the presentation. So how do we determine heart axis? This is kind of like the step-by-step version of that, okay? So first, of those 6 leads, so we have leads 1, 2, 3, AVR, AVL, and AVF. Those first 6 on the left-hand side of your EKG, okay? You're going to find the lead with the greatest deflection, so the largest QRS, one that has a really tall QRS, okay? So the lead with the tallest deflection from the isoelectric line is going to be, we'll match that up with our chart to figure out what angle that is and if that is a normal axis. So if the QRS is positive, the angle be at a positive position on the wheel. That makes sense? I'm going to put myself right in the middle here. The lead with the smallest QRS deflection should be its opposite. So you're like, how do I figure out the opposite? I'm going to show you that too. And then always confirm the opposite angle 90 degrees away on the wheel. So we're going to do that too. Okay, so we're going to figure out what the tallest is, and then we'll confirm it by going to its opposite, which is the smallest. And if that confirms out, we match up the tallest QRS with the angle on the wheel, and that will be our heart axis. It sounds like a whole lot, but once I walk you through it and we do it a couple times and you memorize it, it's pretty easy to do. Okay. All right, so here we go. Just trying to find a perfect place for my space. Okay, here's my face. All right, here we are with just some options or ideas of where the tallest QRS might be. Okay, so if we looked at an EKG, we see 1, 2, 3, AVR, AVL, and AVF. Okay, I'm actually going to switch over, I think, to the EKGs examples that we have in our packet. So you have an EKG example number 1 in your packet. Okay, go ahead and flip to that. That's the next page after the wheel. Keep the wheel next to it, and so you can refer to it and go back and forth to it. And I'm going to do the same. We're going to go back and forth, okay? So I'm going to switch over. I'm going to go back to the wheel where we had it. Back to the wheel. This wheel. Nope. I'm going to go back to this one where I had all these on it, okay? Now I'm going to pull up my camera so we can take a look at the EKG together. I'm thinking it's actually forward ahead a little bit. I'm going to go forward ahead so I can maybe see it on here a little bit better. Ah, yes. Okay, here we are. We're on practice number 1. Okay, so you have this in your packet as well. So the exact same EKG in your packet. I just think you can see it better here than in the packet. All right, so have your wheel close by. I have my wheel that we've created. I'm going to sit it right here next to me, and then we'll go through this together. So I'm looking at 1, 2, 3, AVR, AVL, and AVF. And I'm looking at the size of the QRS. Let me backtrack real quick. Let me do that side note, that AVR negative. We noticed that AVR on the wheel was negative, right? AVR. Notice that AVR, the QRSs are upside down. They're supposed to be upside down, okay? If they're not upside down, your leads are probably on incorrectly, your limb leads. And why is AVR always upside down? Remember where AVR direction went. Lead direction. So it's landing on the right arm. So it was the left arm and left leg meeting in the middle and going to the right arm. Remember I said it was going away from the heart, so that conduction's going away. Since it's going away from the heart to the right side, away from the apex, it's going to be upside down. So this is another indication of whether or not you have your EKG leads on properly, is if AVR is upside down. Okay, the QRS should be upside down. All right, so back to what the real thing is, the heart axis. So we're looking for the largest QRS of these 6. This one, this one, this one, this one, this one, and this one. We can do Einthoven's triangle. Remember, 1 plus 3 should equal 2, which it does. Stack this on top of that, and that should equal that. It does. Einthoven triangle checks out, and our AVR is negative. So we know this EKG is hooked up properly. So let's take a look at the size of the QRSs. So for me right away, this right here looks like the tallest QRS to me. Okay. You can take a look again. We're looking at this QRS in 1, this in 2, this in 3. Of those 3, this is definitely the tallest. Then we have this one in AVR, AVL, and AVF. So of those 6, this is definitely the tallest. So on my wheel, I'm going to be like, lead 2 is definitely the tallest. So I'm going to go to my wheel and notice that lead 2 is actually positive 60 degrees on the wheel. Okay, and I'll show you real quick with my camera so you can see how I did that. So we determined that lead 2 was the tallest QRS, and on the wheel it equals 60 degrees. 2 is 60 degrees. Okay? So we need to double check our work. We're going to make sure that the opposite of this is the smallest QRS of those 6. So how do we take the opposite? It's 90 degrees away on the wheel. Okay? So if I follow this for 90 degrees, whoop, whoop, I end up over here. That's 90 degrees. I end up over here at negative 30. So AVL is the opposite of 2. So now I need to go look over at AVL, which I'm going to do. I'm going to look at AVL. So let's close this down for a moment. Let's look at AVL and see if that is the smallest. So we said this is the tallest. And opposite to that is this one. Is this the smallest of the QRSs? It sure is. It's barely there. It's teeny tiny, right? So 2 and AVL are always opposites. So if I think this one's the tallest, I'm going to automatically look at this one to be the smallest. Right off the bat, we can tell that right away. Okay? So on your number 1 EKG on your picture, I'm going to do this. I'm going to be circle 2 and AVL are opposites. I'm going to link those 2 together. I'm going to show you my camera again. I know I keep flipping back and forth, but I'm just hoping it's easier for you. So here's my picture. This is your notes too. This is the same EKG that was on the slide. So we saw that this had the biggest QRS, and its opposite is over here, and that is the smallest. Okay, so I know that this is definitely the tallest. Okay? And we determined that this was positive 60. So the heart axis equals positive 60. I can write that right on top of my EKG. We did the Einthoven's triangle before too, so we can do E triangle equals yes. Okay, so let's do some cheats for this. Let's try a couple other things. So we know that these 2 are opposites. I'm going to go back to my wheel, which I think is just underneath it here. Nope, it's at the bottom. Back to my wheel. Let's start with lead 1. That's the one up top on our EKG. 90 degrees away from lead 1, or 0, is 90. And that happens to be AVF. So 1, the opposite of lead 1, because it's 0, 90 degrees away, is going to be AVF. So let's see what that looks like on here, on our EKG. Here's lead 1, and its opposite is AVF. So these 2 are always opposites. If this one's the tallest, that one has to be the smallest, and vice versa. It's not the case in this particular EKG, but if this was the tallest, that would have to be the smallest for it to be confirmed. We got one more to do, don't we? We have lead 3. 2 and AVR we determined are always the same. 2 and 90 degrees away is AVL. We got that one already. They're right next to each other. And then lead 3, right here, 90 degrees away from lead 3, is going to be positive 30 or AVR. So 3 and AVR are also opposites, because they're 90 degrees away on the wheel. Okay, so these are my always tried and true, never change opposites. If I find the tallest is in lead 3, I will automatically look at AVR to see if that is the smallest. And if it is the smallest, that confirms that lead 3 is the tallest, and therefore my hard axis is whatever lead 3 is. So this is one little cheat you write down on here, and do it just like I did, okay? Little cheat code, if you will, of the opposites. You don't have to look at the wheel, just have to understand what the opposite is and where we got it from, okay? So what we need to memorize now is what degrees each of these are. And it goes in a pattern. It's actually pretty easy. This is 0, 60, 120, well, positive 120, okay? Then over here, I'm going to go back over so you can see what I did. Lead 1 is 0. Lead 2 is 60. Lead 3 is 120. 0, 60, 120. Okay. So when we come over here to AVR, AVR, as we can see, is positive 30. Positive 30. AVL is negative 30. And AVF is 90. Positive 90. So they will always be that. So now you just have to memorize them in your brain. Kind of like the same thing we did with the countdown method with the heart rate. It was a 1500 method. Let me straighten these out a little bit. It's a 1500 method that we had to memorize, 300, 150. So now we just have to memorize that lead 1 and AVF are opposites, always. These two are opposites and these two are opposites. This is 0, 60, 120, positive 30, negative 30, and 90. So now I know I can pick up the hard axis right away no matter what. In fact, let's go down to the second EKG down here. Okay. Using this little cheat sheet right here, I want you to use yours. I'm going to switch over to the slides just because it's easier to read. And I want you to have this on the side and get ready to do the hard axis for number 2. All right, so here's number 2. So for number 2, same thing on your worksheet, okay? Looking at leads 1, 2, 3, AVR, AVL, and AVF, which one is the tallest QRS of those 6? Take 30 seconds and figure that out. You can circle it on your paper if you'd like, on your note sheet. Which one you think is the tallest. And then if you think you know what the hard axis is because you've confirmed it, the opposite of it is the smallest, and you know that the hard axis is the number, you need the hard axis to be the number, degrees. Write that down. All right, I'm about to give you the answer, so if you still want to try and figure it out, pause it, and because I'm going to give you the answer. Okay. So the answer for this, the hard axis for this one is positive 60. Did you get that? Awesome if you did. If not, that's okay. We're going to walk you through it. Okay? All right. I'm going to switch over to mine. Now, let's do it up here. Okay, so of these 6, I'm looking for the tallest QRS deflection, right? And I know a lot of you are like, well, clearly it's 2. I agree with you. 2 is definitely the tallest of all of these. Agreed. Now, if I look at its opposite, so now I need to confirm this is really the tallest. Okay, sometimes we have some QRSs that look at this around the same size. We're not sure which one is actually the tallest. We look to the opposite to find the smallest. Okay, so its opposite, if you remember, 2's opposite is always AVL. These 2 are opposites, these 2 are opposites, and these 2 are opposites. So AVL, the QRS here is almost non-existent. It's right there. This is definitely the smallest, so this confirms that this is the hard axis. Okay, but we don't put down lead 2 as the hard axis. We need to put down the degrees that it coincides with lead 2. And remember, this went 0, positive 60, 120, positive 30, negative 30, 90. So this lead 2 is positive 60 on the wagon wheel. Okay? Redo it again if you're not sure. Just rewind and try again. We're going to move on to number 3. Okay, I'm not going to say anything for number 3. I'm going to let you guys try and figure it out. Remember, for leads 1, 2, 3, AVR, AVL, and AVF, look for the tallest deflection, the tallest QRS. When you think you have it, you circle it on your paper. This one's a little tricky, believe it or not. So when you think you have it, go to its opposite and see if the opposite of that is the smallest. Confirm your findings and see if that is the smallest QRS. Okay, once you just confirm that that's the tallest, write down the number of on the wheel, the degrees, the angle at which it sits. Okay, I'm about to give you the answer. There's actually 2 answers. There can be 2 answers for this. So I'll explain it the easy way for you first. And if you're still working on it, pause so you don't get the answer. Okay? All right, here comes the answer. So did you get 0 degrees for your hard axis? If you did, congratulations, you did a very nice job. And that is, we got this by going that this is probably our tallest QRS. Of these 6, this is probably the tallest. Now we had to confirm that by going to its opposite, which is here. And this is pretty small, but is it the smallest one of all of them? Because look over here, this is pretty small too. It's negative, but it's still pretty small. We're just looking at the size. It doesn't matter if it's positive or it's negative. We're just looking at the size, okay? They're kind of about the same size. But if you called it 0, that's fine, because this would be the smallest, this is the tallest, and we'll go with 0. What if this was the smallest? The opposite of 3 is AVR, okay? Now, this is a negative deflection, but it's definitely tall, correct? I can see, though, that this is 1, 2, a little bit taller than 2 boxes, and this one is exactly 2 boxes. So this is definitely going to be our tallest one, even though these kind of look similar. Another way to do this is if you think that these 2 smallest are exactly the same size, like you can't tell the difference, you would take the difference between the 2 hard axes. So this is 0 if this was the tallest, and this is positive 30 if this was the tallest. Opposite of here, opposite of here. If we think they both are the same size, and these are the same size, we'd go halfway between. So halfway between 0 and positive 30 is positive 15. Yes, you can do that. That's a little more confusing, a little more advanced. We'll work on more of that in class. But I'm just throwing it out there to kind of get your mind thinking, okay? So that's what that would be, all right? I am perfectly fine with the hard axis being 0 for your answer. And if you said 15, and if you said positive 30, they're all close enough, right? It's still in that normal range. We're not worried too much about it. All right, great. And that's it. I will see you next time. Rewind anything if you need to, and I'll see you next time.